about memory management and specifically how the stacks and heaps work as part of this Java memory management. I'm going to do that by walking through some code that we have here. We're going to go line by line, and we're going to talk about what goes into the stack and what goes into the heap. When you first run your program, before I even get into the program, I have an empty stack, which means I have no variables or primitive data types or references available, and I have no objects sitting on the heap. So let's go ahead and work our way through the code now. So when we first come into a program, we come in through the public static void main, and in there we're going to create a local variable of an array of strings called args. So the very first thing that happens when I come to main, I make that local variable on my stack from the main. I make an args reference to an object of arrays, and they're strings. So you'll see I listed in a stack that I have that local variable of my reference to my object of strings that's sitting out here on the heap. Then we're going to make an object of the demo class. So you can see that our public static void main is actually in our demo class. So we're going to make a new object of it. So we're going to go make a reference to the D, which is the instance of the demo class. You'll see over here in the heap now I add another object that's named D, and my reference from my stack points to where that's located in memory. The next line is I call a method, method1, and I pass in a 4. 4 is not necessarily, or it's not a local variable, it's just a number 4, but that number 4 gets created as a local variable within method 1. So on the heap now, or on the stack, we need to create an A instance and set it equal to 4. So that's a primitive data type, so there's no corresponding heap aspect. We go on to the next line. Here we create another primitive data type of a type char and C, and we set it equal to X. So on the stack goes the method1 C variable with a value of X. It's primitive, so there's no corresponding heap component that goes along with it. Now we make a call to method2. I'm just going to pass in the C that already exists, so I don't have to make any new piece there. But now method 2 needs a local variable because it doesn't have scope for C is not in scope for method 2. So the C value, that X, is going to go into my local variable called char A. So my method 2 now has a primitive data type of a char A, and that's equal to X. Notice my C value and my A value are two different entries in my stack. Because it's a primitive data type, there's no corresponding heap entry. Now I'm going to go ahead and make a string called B. String, if you remember, is not a primitive data type, and in fact it is an object. So when I do string B equals Java, I'm going to have to go ahead and create an entry in my heap called B of a string type, and then we're going to go ahead and put Java there. So my stack's going to have a reference to that object on the heap. It's not actually going to store Java over here in the stack. It's going to point to where Java is stored in the heap. The next two lines, I'm going to go ahead and make an object of Ninja called Ninja1. So I'm going to make an object reference in my stack called N1, and I'm going to point to where that particular object or instance is stored in the heap. Now, my class has two attributes, a string and an int name, or a string name and an int age. Those are contained within that heap environment over here. So they're not contained in the stack. In this aspect, they're actually stored as part of the stack or the heap that goes along with that N1. Same thing when I make Ninja2. I go ahead and I make a reference to it in the stack called N2, and I make an object in the heap, and I use the same object that I did previously called Ninja, and it's a string of a name and an int of an age, but now I have two objects of Ninja sitting in the heap. At this point, if we follow what happened here is we had a call from our main to our method 1 and from our method 1 to our method 2. When you get to the end of the method, this method is over with, and it's going to go back automatically to where it called it. So when method 2 is over with, it's going to go back up to where it called it. That's immediately the end of method 1 because there's nothing else to do, which goes back up to main. That was the last call in main, which means we're ready to leave the program. So let's go ahead and backtrack now through what's all happening. So that's the final structure of all of our stacks and all of our heaps. So first thing we're going to do is we finished off method 2, so we're going to go from method 2 back up to method 1. As soon as I leave method 2, all the stuff that were declared in scope in method 2, the char A, the string B, the Ninja1, and the Ninja2, all are removed from the stack. So there's the N2 going away, the N1 going away, the B going away, and the A going away. All of these objects that got created as part of the string and ninjas are now available for garbage collection, and Java does that automatically. You don't need to worry about it. It's handled from the JVM perspective. Now that I'm done with Java 2, or method 2, I can go back up to my main. So anything that got declared or needed in method 1, including my int a and my char c, are now out of scope. You see those are going to be removed from the stack. There's my c of my x, and my a equals to 4. There was no corresponding heap thing, so nothing's going to be removed from the heap at this point. When I get done with method 1 and I go back up to main, that was the last call that was done in the main method. So I'm actually finished with the main method and I'm ready to leave the program. So you'll see that I have two things that are going to go out of scope. The demo D that I created up here, and also the string arg that was part of my main parameter. So both of those will go out of scope. Both of those are objects, so the references that were in stack are also going to be disconnected. So my D for my object of demo and my args of the string array type are now available for garbage collection, and everything is now out of my whole program. So my stack is completely empty. Everything that I have in my heap is now available for garbage collection. It's very possible Java's already cleaned those up. We don't necessarily know, and we probably don't necessarily care at this point, but these are available for garbage collection and will be handled appropriately. Now, I do want to take just a second to talk about strings, because we've mentioned this a couple different times, and we talked about the fact that strings are immutable, which means we cannot change the value of a string. So in memory, what really happens when we change the value? Because we already know that we can change the value of a string just by setting it equal to something else. But in memory, it's handled a little bit different. So in my, my method 2 here, I create a variable called b equals Java. So that is an object. So in the heap, I create a b of a string data type, and I set it equal to Java. And in my stack, I go ahead and point to where that one's located. But the next line down there is I go ahead and say, okay, b instead of equal to Java now equals C++. Well, it doesn't actually change that object from Java to C++. What it does is it creates a new object of the string data type. That reference now points from one method or one object in the heap to another one. So the previous one is now available for garbage collection, where this reference now points to the C++ object that's stored in the heap. So this one didn't change. I didn't change the value of this object. I just changed where my reference pointed to. So previously it pointed to the Java environment or Java object, and now it points to the C++ object in memory. So that's a little walkthrough of memory, both handling from the stack and the heap perspective. Thank you very much.